let's let that load up. There it is. All right, what do you see here? Where would you start if you were working on this on your own?
The left side's probably more complicated.
Agree. Anything stand out to you on that left side?
Let me pick up my pen. Okay. I'm not sure if this one involves Pythag identities, but
Not yet.
Yeah.
Not yet, because there's no squareds.
And
I
so
made
for
that.
this
Go ahead.
for this problem, would you make the tangent would you make everything sine and cosine?
Let's try it. I don't know. It should work. So let's try it. 1 over cosine alpha minus sine alpha over cosine alpha. Okay. Now what?
What do you call it? You have to combine them.
Okay, so go 1 over 1 minus sine alpha over cosine alpha. Now the analogous problem here is 1 over a over b becomes b over a.
Yeah.
So this becomes cosine alpha over 1 minus sine alpha. Now I'm not going to say this is wrong. I'm going to say you still haven't done the thing that you probably do in these problems, and you can't use the sine and cosine thing anymore, so you have to do this. It's related to the bottom here. Remember that list from yesterday? I gave you like 6 or 7 things.
Oh, yeah.
One of them has to do with conjugate pairs.
1 plus. So this is a 1 minus or 1 sine.
Yeah, so you're gonna
So you
multiply.
do the reciprocal?
Well, no, top and bottom by the conjugate.
Oh.
Top and bottom by the conjugate.
So the conjugate is the opposite of like the 1 minus sine.
That's the conjugate. You just change the operator from a plus to a minus or a minus to a plus.
Okay.
So I'll just point this out. You could have done that from the beginning. I looking ahead, it looks like this way will work and be just fine, but you do have to some point do this. Okay, so I'll do the top. You're going to have to tell me what the bottom becomes.
So for the bottom, I just multiply everything.
Foil it out. You should see some cancellations.
So 1 plus sine alpha. Is it wait, I think I did this wrong. Oh, that's what I did. Is it 1 minus sine alpha?
1 minus sine squared alpha.
Oh, sine, yeah.
Okay. Now, whenever you see a squared, you should think identity. Pythagorean identity. I don't have the cheat sheet up, but I'll snip those in. Here we go. Okay. Which of these are you going to use?
The first one.
Okay. So how do you use the first one on the bottom?
1. Would that equal cosine squared?
Yes. So it becomes cosine alpha, 1 plus sine alpha over cosine squared alpha. Now, really important to at some point, remember what you're going towards. Because getting lost in the woods, that's no good. And that's where you could be at this point. It's like, well, am I even getting closer? You actually are, but I mean, I would make sure you always sort of say, well, oh, there's a plus. That's kind of like encouraging. What do you do next here? What do you see?
Well, you're gonna have to convert it to secant and tangent. So cosine would the cosine become 1 over secant squared?
It does,
On
but
the
you don't want
bottom?
to. You don't want to do that. You don't want to do that. Do you see any cancellations?
Oh, the cosines cancel.
Yes. So there's a cosine left on the bottom. 1 plus sine alpha over cosine alpha. You're so close. You're
Cosine. So now you would make the bottom 1 over, or now, wait. Where's secant at? Would the bottom become 1 over secant?
it does, but you don't want to do that. You want to split these apart.
How do you know when to split them?
I don't know, other than you've got to visualize the plus. This plus matches that plus.
Is that literally it?
That's it. I'm sorry. These aren't like so there's people that do code breaking and pattern recognition, and it's not, you can teach some of the skills, but you can't teach all of them. You ever played poker before or know about poker? Reading
Yeah,
people?
I know about it. Yeah.
It's more a game about reading the people at the table than the actual, because everyone knows the numbers. Everyone knows the probabilities of winning. It's like, what do you think that person's going to do? I'm sorry. This is not like, it's not like science, not like pure science. It's but there you have it. 1 over cosine is secant. Sine over cosine is tangent. So your way worked. It's very, very good. All right, we'll do the same thing for the next one on this list here. Which one stands out to you?
You just do 52.
52, okay. Okay, which side are you going to work on here?
Oh. I mean, the right side? I mean, it's not in sine and cosine.
So there was a
Oh, wait.
rule.
Oh, I'm looking at the wrong problem. Sorry. Yeah,
Okay,
left side.
am I sharing my screen correctly? Just make sure.
Yeah, you
Yeah,
are.
okay. So you tend to go from the plus to the non-plus, we'll say, which means to work on the left. Okay, so yeah, that doesn't get you much, but it it starts you out here. What say you? What should we do from here?
So this is one of those 6 rules, and then that's the conjugate.
Yeah, so I'm gonna suggest we go. Let me rewrite it here. 1 over 1 minus sine theta. 1 over 1 plus sine theta. 1 plus sine theta. 1 plus sine theta. 1 plus sine. Oh, sorry, this one's gonna be a minus. One minus sine theta. Okay, so you're gonna have to do the bottom for me again.
So the bottom is, or the bottom for the first one is 1 minus sine theta squared, or sine squared theta.
Okay, good.
And left side, 1 minus sine squared. And then up the right side is also 1 minus sine squared theta.
Yes.
Oh wait, no, yeah, oh yeah, okay.
So that's good. What's the what do you do from here? Not the bottoms are the same.
You can't cross cancel, right?
No, but again, like the analogous problem is you've got A over B plus C over B, A plus C over B.
Oh, you have to combine them.
Yes. So you get 1 plus sine theta plus 1 minus sine theta over 1 minus sine squared theta. Ton. Just what do you see there? Anything stand out to you?
Let me put some lead in my pencil real quick.
Sure.
The sine squared would cancel with the sign on the right, right? Or not
So
cancel, but it's
there's
the bottom would become 1 minus sine.
no, there's implied parentheses here. So unless you see exactly what's in the top and the bottom, you cannot do what you just said. Try to just focus on the numerator. What do you see there?
The sine thetas cancel.
Yes. What does the top become?
2.
Okay. Now, we did this in the previous problem. When you see a sine squared or cosine squared, or more specifically a 1 minus sine squared or 1 minus cosine squared, that's an identity. You're going to use one of the Pythagorean identities on that one.
1 minus. So that would equal that's the first one.
That's right.
Cosine squared. It equal, would it be negative cosine squared?
It's so like the way that to answer your question, you're off by a sign. Like when you see this first one, let me just show you here off to the right. There's a couple of ways that you can use it. And the most of the time you're gonna be solving for a 1 minus cosine squared or a 1 minus sine squared. And these just equal the other one.
Oh, okay. So this is the other one.
Yes.
Okay.
But it's got to be 1 minus, not 1 plus. Okay. Again, always good to remember, like, well, what am I even trying to get this thing to, so that I know, have I reached my destination? And here's your destination. Is that what this is?
No, it isn't.
It's really close though. You're almost there. What is 1 over cosine squared?
Secant squared.
Yeah. So this becomes 2 secant squared theta, like that. Good. $53 next.
Yeah.
Okay. All right. Got 1 minus cosine x on the left, 1 plus cosine x on the bottom. equals cotangent x minus cosecant x squared. Which side do you want to work on?
The right side.
The right side we will have to work on probably, but not first. The fractions are harder to deal with than anything. So I don't know if you want to add that to your list, but generally you work on the fraction side.
What about if they're both fractions?
Great question. You tend to work on both of them. This is probably a both problem because they're both reasonably complicated. 51 and 52, 52 to or 51 to a lesser extent, but 52 you could see that the left side was more complicated. The right side is really simple. We're going to work on the left hand side on this one, at least for a while.
Okay.
Okay, so tell me what to do from here based on that kind of list.
I have to remember the word. The conjugate, yeah.
Conjugate, yeah. Okay, so I want you to multiply the bottom.
So it's 1 minus cosine squared x.
And so is the top. So what does this simplify to?
Hang on. Let me just put some notes down. Would it be 1?
Yes. And that's not even close to what the right side is. But it does indicate that we probably, I mean, the right side probably becomes 1. So this is one of those like both sides. So
So would you have to make these into sine and cosine?
I would first foil, or not foil, write it out so that I can foil. So I'd write cotangent x minus cosecant x, cotangent x minus cosecant x. Go ahead and foil that for us, please.
So foiling means multiply everything, right?
Yes.
Okay. I'll skip kind of long. Is it cotangent squared x plus, or wait, cotangent squared x plus cotangent x times cosecant x?
It's minus, because the cotangent times the cosecant gives you minus, cosecant times costangent gives you minus. It's minus 2.
Oh,
And the order doesn't matter. I think you said cotangent, cosecant.
yeah, I forgot to combine them. Okay, got it.
Okay, so now we know this goes to 1 somehow. What do you see from here that might be useful?
Um, so would they all become fractions?
Here's your hint.
Oh, cosecant squared x equals 1 plus cotangent.
Okay, so I like that. So that means you're going to substitute in. So we got cotangent squared x minus 2 cosecant x cotangent x, and then we're going to put in 1 plus cotangent squared x. Okay. Problem with that is you did not get rid of the, like, you've now got 2 cotangent squareds, which isn't good, which is not good. Just double check your work here. Okay, so if we go the other way, we still have the same problem. Did I get the signs right on this? Okay. Well, okay, so this one's messier. It's getting messier, not before it gets better. Let's not do that. Because that didn't seem to work. I apologize. So let's look at the middle one here. Cosecant is over sine. And then cotangent is cosine x over sine x, like that. For that middle one.
Hang on.
Actually, this may not even be useful at all.
Yeah, I got that. So you
Okay.
just made the middle one into cosine and sine.
Yes, and this first one moves cosine squared x over sine squared x. And then this last one becomes 1 over sine squared x. So they actually all have the same bottom, which is nice because you can make everything over now sine squared x. So this becomes cosine squared x minus 2 cosine x plus 1 in the numerator.
Cosine squared.
But this is where it gets a little bit more challenging. This is kind of non-obvious. You do have to factor the top. And the top factors into cosine x minus 1 squared. I really feel like we are way off on this one. This one's not working out the way it's supposed to. Sorry, let me just look at this one more time. One plus cosecant x. Oh, I'm sorry. That's why this isn't working. I messed up on this beginning. My part I did wrong. That's why this is so wonky. Okay. Sorry about that. Let me start fresh here. It's just really messed this up bad. Okay. So I messed up the left side. I didn't multiply the top and bottom by the same thing. So we got 1 minus cosine x, 1 plus cosine x. You have to multiply the top and bottom by the same thing. And that means the conjugate, but it's the same on the top and the bottom.
Did you use the conjugate for the denominator?
You have to use, no. What I did is, yeah, I did 1 plus cosine x. I did just literally just not paying attention. That's all that was. You multiply the bottom by the conjugate and the top by the same thing. These have to be the same. So the top becomes 1 minus cosine x squared, and on the bottom it becomes 1 minus cosine squared x. Which is on the bottom sine squared x. Like this. Okay, so let's just leave that because that looks pretty bad for now. And then we'll do this other part, okay, which we kind of already did. We got cotangent squared x minus 2 cotangent x cosecant x plus cosecant squared x. All right, so now from here, I made the point that this was cosine squared x over sine squared x. 2, and this ended up being sine squared x in the bottom, cosine x up top, plus 1 over sine squared x. So what we now have is sine squared x in the bottom, cosine squared x minus 2 cosine x plus 1 on the top. Now they're looking really similar. Would you agree? They're looking really
Yeah.
similar. So the question is, well, if you're not comfortable factoring this, then you have to FOIL this. So we'll do the left here. 1 minus cosine x, 1 minus cosine x over sine squared x, and we get 1 minus 2 cosine x plus cosine squared x all over sine squared x, and now they are the same. Any questions on that? Sorry for mistake again.
No, I mean, it makes a lot more sense now.
Yeah. Okay, so next problem on the list here. Let's see here, 54. Kind of like the last one. Try really hard to not mess this up for us. All right, so which side should we work on?
Left side is fraction. So you probably have to do both sides, right?
Possibly, yeah. Like we hope really hard that it's this. Now, I'm gonna not allow the same same thing here. And we're going to multiply the top and bottom. So it's going to be 1 minus cosine s, 1 minus cosine s. Or sorry, this one on the right is 1 plus cosine s. So I want you to factor or FOIL the bottom, sorry. And then we'll look at the top.
So the left side is 1 minus cosine squared s.
Yes. And do you see that they're both 1 minus cosine squared? Oh, we're still getting to that. I'm sorry.
Yeah, they would, because they're the same.
Yes. So what's really good is if you can combine them in as few steps as possible. And you're probably starting to notice this, that whenever you have a 1 minus cosine squared, you convert that to what do we convert this to in the last few problems? The bottom I'm talking about. Sine squared. Yeah.
Yeah.
Okay. So this and that is really a common thing to do. Like it's not a strategy, but it is something you do in a lot of these problems. So this bottom becomes sine squared s. Anything now stand out to you?
You know, let me finish
Sure.
this real quick.
Sure. Yeah, no, it takes a while to write down.
So I want to say that the signs cancel, but
You have to divide both. It's not like a choice. You have to divide the left by sine squared and then the right by sine squared. I'm sorry, that's only a one when there's sine. So you have to break it apart so that they're both is that okay?
yeah.
Okay, now there is some cancellations, and you just said one of them, right? You said, oh, it's this, what happens on the right? That's probably the easier one. What happens here on the right?
The sign on the top goes away, and then the bottom is just sine.
Okay. So now let's work on that little piece. 1 plus cosine s over sine s. And maybe from an earlier problem, you can say what to do from here.
Would it become 1 plus cotangent?
It just like the previous one, you have to divide both of them by the sine s.
Oh. And then now it'd be 1 plus cotangent s.
What about the 1 over sine s? What is that?
Oh, that's cosecant.
Cosecant s plus cotangent s. This is a good time to look at your answer and say like, well, is that in the answer?
No, it isn't.
Well, part of it is and that you're just looking for a little hope, a little shred of like, well, am I getting closer? There's a cotangent there. That's good. And there's a
You're just
cosecant
fixing the
s,
secant.
right? But we haven't worked on this part on the left, so maybe that'll help. But you've got to believe you're getting closer to it. So let's work on the left now. It is very similar. You can't just cancel tangent with sine, but you can do something here.
Would you split them apart, or would you make the tangent into sine over cosine?
Sine over cosine for tangent. 1 minus cosine here all over sine squared s. And yeah, this looks worse. I mean, it does look worse before it gets better. But that's okay.
Do the signs cancel?
One of the signs cancels. Yes, that one on the top cancels with that one there. And so it's a little odd, a little awkward, but this sign ends up coming up down into the denominator. So it ends up being 1 minus cosine s over sine s cosine s like this.
So this would become 1 over sine s minus cosine s. over cosine S.
You split, the thing on the bottom has to be given out to both.
Oh, okay.
But that gets you really close. You're so close here.
So
Let's do the one on the right. I think that's one's clear. The cosines cancel. And what are you left with?
sine or sine S.
On the bottom, what's on the top?
Oh, 1.
Okay.
Yeah.
Okay, and that's good because that is really cosecant S, and it's negative, so it cancels out with that one there, which is positive. That's good. That's really good because the cosecant S is not by itself, it's with the secant S. On the left here, do you remember how to handle this?
So it'd be 1 over sine S plus 1 over cosine S
times.
times.
Yeah, you can't turn that product into a sum. But okay, so what is 1 over sine S?
1 over, that's cosecant.
Okay, and then 1 over cosine S?
It'd be cosecant times secant.
Good. So now if we bring this next part down, plus cosecant S plus cotangent S, we're just bringing these down. We're in really, really good shape.
The cosecants cancel.
That's right. That's right. And if you're looking ahead at the answer, you're like, oh, that's good. That's really good news because my answer is cotangent S plus cosecant S secant S, and that's the same.
Yeah, I have to copy this. Got it.
Okay, let's look at 56 because you brought that one up. I think it's a good one. Cotangent alpha plus 1, cotangent alpha minus 1, 1 plus tangent alpha, 1 minus tangent alpha. Is there a side here you think that we should work on, or both?
The left side.
Sure, why not? Now, do you want us to, there's two options here, convert everything to sine and cosine, or multiply by the conjugate. Which do you want to do here? I don't know the answer, so we're just going to do whichever one you say.
I feel like conjugate would be less complicated.
Okay, let's give that a try here. So we've got cotangent alpha plus 1, cotangent alpha minus 1. So it's the conjugate of the bottom. Cotangent alpha plus 1, cotangent alpha plus 1, like this. All right. So that tells us the top becomes,
Oh.
you have to FOIL it. So it becomes cotangent squared alpha plus 2 cotangent alpha plus 1. On the bottom, it becomes cotangent alpha or cotangent squared alpha minus 1. What do you see from here?
The cotangent squared cancel.
Again, there's implied parentheses. They can only cancel if you have everything.
I keep forgetting that.
Yeah.
Okay. Let me write a note here.
So I say the words implied, meaning you're supposed to remember they're there even though they're not written. I mean, it's like the invisible electric fence.
Does a Pythag identity?
Yes, yes. Let me snip those in again.
So that would equal cosecant on the bottom.
So if you move the one over,
Yeah, let me write. Let
so
me
you gotta
do
be
this.
gotta be careful because it may or may not be the one you want it to be. So the way this is written, if you solve it for cotangent squared, you get cosecant squared minus 1. This one doesn't work as nice there, but it actually does work in the numerator.
Oh yeah, because the numerator is just cotangent squared plus 1.
Yeah, so that becomes cosecant squared in the numerator. The denominator doesn't actually help us that much, believe it or not. This may have been one of those to go to sine or cosine on, but we haven't worked on the right yet either, so can't say for sure. Just looking at this again. Oh, these are not clear. It's not clear where to go. Yeah, the conjugate doesn't always work, unfortunately. I'm gonna suggest we restart here using sines and cosines. So cosine alpha over sine alpha plus 1. Cosine alpha over sine alpha minus 1. And we're going to make a common denominator here. So sine alpha, sine alpha, sine alpha, sine alpha, like that. So the top becomes cosine alpha plus sine alpha over sine alpha. And then the bottom becomes cosine alpha minus sine alpha over sine alpha. And the bottoms end up canceling. So you get this cosine alpha plus sine alpha over cosine alpha minus sine alpha. And we're gonna stop for there for a moment and go back and work on the other side. We're gonna do the same thing though. So I know you need to get caught up, but just since running short on time, let me do this. That's 1 plus sine alpha over cosine alpha. 1 minus sine alpha over cosine alpha. And so you're gonna do the same thing. You're gonna make that common denominator again. So this is cosine alpha, cosine alpha, cosine alpha, cosine alpha. You get cosine alpha plus sine alpha over cosine alpha. That's the top. And then cosine alpha minus sine alpha on the bottom over cosine alpha. And again, the bottoms cancel. Look how nice that is. So this would be a good one to practice. You can see it does work out to be the same. Though unfortunately, the rules don't apply to all situations at all times. You do have to.
Yeah.
But so I got discouraged. I guess I didn't share that. I got discouraged over here because I was like, well, this isn't really any better. And then I got pretty excited when I saw that these were going to cancel. That's the kind of like little victories, little things that say, oh, this looks better. Oh, it doesn't look better. Maybe only go one more step if it doesn't look better. All right, so I know we didn't get through all of them.
Oh no, this helped a lot.
Okay, yeah.
Yeah. The
Um,
only thing is, it's just like, it's difficult to know which direction to go to with these problems.